Howdy. I'm expecting this video on quadratics and exponentials to be a little less familiar for a lot of people, so I'm going to go a little bit more slowly in this one and assume that less of this is review than I have been in the other ones. And remember, there are those other videos with the full lectures as well. So this is not going to be a full lecture, but it's going to be a little bit more in depth than these videos usually are. So we're going to start by looking at question number 1. Give the y-intercept as an ordered pair and the x-intercepts as an ordered pair if they exist. And then follow the instructions for how to input your answer. Okay, so let's first find the answer and then we'll worry about how to input it. So the x-intercepts, remember we've talked about x-intercepts before. X-intercepts are just where it crosses the x-axis. So this is the x-axis up here. These are the x-intercepts. And it wants us to put them as points with a comma and no space. So the first x-intercept is at -5. That's when x is -5, comma, y is 0. And if there's another one, it says, put your answer like this. The other one is going to be when x is +4 and 0, just like so. Okay, the y-intercept, that's going to be where it crosses the y-axis. So where it intersects this axis right here. Can make it a little bigger. Open image in new tab. I think that should work. Oh, that downloads it. And so if you ever want to see the thing a little bigger, you can download it here and you can zoom in. You can make it real big if we wanted. It's at -20. Now the x coordinate of this point is 0 and the y coordinate is -20. All right. So 0, -20, make sure we're inputting our answers correct. Read the instructions. If there's more than one intercept, separate with an ordered pair. Separate the ordered pair with a comma, no space. We did it. Instructions, especially on the Canvas ones, are pretty finicky. All right, let's look at number 3. Would the value of a in the equation of the graph be less than 1 or greater than 1? Well, what a is it talking about? So there's a couple of equations that we can use to talk about parabolas. One of them is ax squared plus bx plus c. Another one is a times x minus h squared plus k. This guy on the right is called vertex form because it gives you the vertex. The vertex is the point hk. The vertex of a parabola, make sure I don't. Vertex of a parabola is just that bottom or that top point. Just like so. So this form over here is really nice because it basically tells you everything you need to know. Whereas this guy over here is a little easier to work with a lot of times, but then it doesn't tell us as much information as obviously. So the question is asking us about a. I haven't told you about a yet. What does a represent? So a has to do with whether it opens up or down. So for specifically, if we have a positive a value, then the parabola is going to open upwards. If we have a negative a value, the parabola is going to open downwards. And the reason for that is because when x gets big enough, this is the term that dominates, right? If x is big, then squaring it becomes really, really meaningful. When x is big, these guys don't matter that much. So that's why the a value is going to decide this whole thing. And specifically, the bigger the a value, the bigger the steepness. So if a is positive, and maybe if it's, if a is bigger, then it's going to look much steeper. And if a is like close to 0, then it's going to look much more like spread out, kind of like this. So that's kind of how a will affect these. And you can kind of see an example of this. If we wanted to graph a function, let's graph y, or let's just make up a parabola. Look at what happens if I make a bigger. It's 2, now it's 3, 5, 10, 100. It's getting steeper. If I make it negative, you can see, well, you can't see right now because my camera is in the way. I'm not using my green screen today, but you can see that if a is negative, the parabola goes downwards. And so you can play around with this a little bit. Okay, let's change this to a plus so we can see things a little bit better. And again, the bigger the a value, the steeper the parabola is going to get. The slope. All right. That's really what it's asking here on this first one. So we know right off the bat that a is negative because this parabola is opening downwards. So is it going to be less than 1 or greater than 1? Oh, that's a typo. I need to fix that. Typo on a. All right, it's asking whether it's positive or negative. So it's negative because it's opening down. What's the vertex? Oh, I said something about a vertex, didn't I? If it's in vertex form, you can find the vertex. It's the point h comma k. And the vertex is just the bottom or top of the parabola, depending on whether it's opening up or down. So this is a vertex. This is the vertex. This is the vertex. This is the vertex. They're all of those are yellow points are vertices. Vertexes. So the vertex, again, I'm going to make this a little bit bigger. That's going to be the top. That's when x is -5 and y is +4. The x coordinate -5, y coordinate +4 is the point -5, 4. Right there. Is this vertex a minimum or a maximum? We haven't mentioned that yet. But it's at the top. This vertex is at the top of the parabola. That's going to be the biggest one. That's the biggest part of this parabola. It's going to be a maximum. Sometimes vertices are minimums, right? If the parabola is opening upwards, then the vertex is the smallest the parabola ever gets. That vertex would be a minimum in that case. So if a value is positive, that means it opens upwards. That means that the vertex will be a minimum. If the a value is negative, it opens downwards, and that means the vertex will be a maximum. That's how these things kind of tie together. How many x-intercepts does this graph have? I closed the big graph, but here's an x-intercept right here. It crosses the x-axis. Here's an x-intercept over here. It crosses the x-axis. I believe there's going to be 2. Great. Moving on to question number 5. Find the equation in vertex form. Hey, we talked about vertex form. And we have multiple choice. Let's not worry about multiple choice first. Let's start with the easiest part of vertex form, the h and the k. I said the h and the k are just the x and y coordinates of the vertex. So in this question, on question number 5, right, we have y equals, I don't know what a is yet, let's not worry about it, x minus h. What do we put here? H is the x coordinate of that vertex. What's the x coordinate of our vertex here? Here's our vertex. The x coordinate is -1. So we're subtracting a -1. We'll simplify that later. Squared plus k. What's our k value? That's the y coordinate of the vertex. What's the y coordinate right here? The y coordinate is 0. We're not up or below the x-axis. The y coordinate is 0. So let's simplify this a little bit. A, let's not worry about a just yet. We're subtracting a negative number that's the same as adding a positive number, right? If I'm losing -1, that's the same as gaining +1. And then plus 0, we don't need to write. So it should look something like this. So let's look at our possible answers. -1. So they don't all have an x minus 1 or an x plus 1. We know it has to be x plus 1. So A is not right. B is not right either because both of these have x minus 1s. C looks really weird. It doesn't even look similar. Maybe it's right, but it doesn't look like what we have. D and E look like the most likely candidates. But we don't even necessarily have to find the value of A because compare D and E. D has a positive A value. E is a negative A value, right? The A is just that number that's next to the parentheses in this form. Well, positive A value means the parabola opens up. Negative means it opens down. Well, ours opens down, so I think it's E. Here's another way that we can check. Say we really want to make sure that we have the right answer. Remember that a graph, the meaning of a graph, is it just shows every single point that makes the equation true. So if I pick any point on this graph, it should make this equation true. So let's pick a point. Let's not pick the vertex because we kind of already used that point. Pick the y-intercept, that'll work. That's the point 0, -1. So again, we think that this answer should be y equals -1 times x plus 1 squared. That's what we think the answer is. So the point 0, -1 is on the graph. It should satisfy this equation. Question is, does it? This is our x. This is our y. Replace the y with what it equals. Replace the x with what it equals. And we have to ask ourselves, is this equation true? Well, when we simplify, we get -1 equals -1 times 1 squared following order of operations. -1 is equal to -1 times 1. Simplify inside parentheses first, then simplify the exponents next. Is this equation true? Heck yes, it is. That doesn't prove that our answer is right, but it would tell us if our answer was wrong. If this weren't true, the answer would be wrong. So it's a way to kind of check your answer. So that's how we're going to go through this. Let's look at the last question, number 6. Match the scenario with either exponential growth, exponential decay, or neither. Okay, so crash course in exponential. Here's what they look like. Exponential growth is like this. This can be like investments, population growth. All sorts of those things are exponential growth. Well, provided you have good investments. All right, but usually we think of investments or population growth. Exponential decay is similar, but it's going backwards. All right. And radioactive decay is a very good situation about this. Let's see. Compounds in the blood changing over time, they're going to go to that homeostasis. I don't know if homeostasis is the right word here, but that equilibrium point. Like say you eat a ton of sugar and it's like slowly going to be wearing off and stuff like that. That sort of thing is exponential decay. Or if a population doesn't have enough like food or something, then the population dying off can look like this as well. I'm not going to really write anything right here. I don't have good ways of saying that. And then remember that we have quadratics, is what we've been talking about earlier in this video. So for these kind of graphs. So looking at these, the number of zombies in a zombie apocalypse. So maybe there starts with a few zombies. And then the zombies bite humans. and there's a lot of humans to bite. And then those humans turn into zombies. And then those new zombies, now there's more zombies. The more zombies can infect even more humans. And the more zombies there are, the more people are going to get bit. It's going to be exponential growth up to a point, and then everyone's dead. That would be more like a logistic model, which starts like exponential growth. We're not covering the logistic model, but that's what we're going to go for here. The humans in a zombie apocalypse is going to be the other way, right? Going to start with a lot of humans, and then, yeah, there's that 1-to-1 correlation between humans and zombies here. It's actually not really 1-to-1 correlation because I'm sure some humans will die for other reasons. The number of times a viral video is watched on YouTube. I actually don't know what what I'm looking for in this question, but I would say that the more people that watch something, the more people are going to watch it, right? Like if a video is exploding, the more visibility increases its visibility. So the growth increases as the number increases. And that's kind of a hallmark of exponential growth. The amount of money that you have in your piggy bank after depositing $20 a week every year for a year, but that's not exponential. That last one, right? You deposit $20, and then next month you deposit 20 more. Next month you deposit 20 more. It's growing by the same amount every time. That's going to be linear, that last one. We're going to say neither. Again, here's another example of exponential growth. Here's an example of a quadratic. Here's an example of exponential decay. And that's kind of what we're doing. All right, let's see how we did. Make sure I entered my answers correctly. I don't want to lead you guys astray. 2 out of 2 points on number 1. 5 out of 5 on number 3. 2 out of 2 on number 5. Great, I did want exponential growth. Cool. Let me know if you have any questions, and have a good rest of your day. Bye-bye.